Hello, everybody, and welcome back to, I say welcome back because I'm so used to saying it, but this channel you've never been to before, whoever's watching this. And I know we don't have a whole lot of people watching right now. I see one, and it might just be me, so I don't know, because this is a brand new channel, just getting started. And what I want to do, first of all, turn this up a little bit. Turn up my sound a little bit so it sounds a little bit better, a little bit louder, and you guys can hear me a little bit better. So what I'm doing here today is I was thinking about some dehumidification stuff here at my house, really. I want to kind of take you guys along for the ride to see what you think about it. You can weigh in the comments. If someone does appear in the live chat here, I'm watching it over here, then I will see you and I can answer your question. Otherwise, we'll answer it on the flip side in the comments section. So here's the deal. In the house here, I have a two-stage Bosch IDS2 system. The humidity remains a little bit higher than I'd like it to be. So what I would like to do is do a little bit of experimentation and manipulation. And I was doing some research on some controls and found some antiquated controls. So I'm going to put those up on the screen. You'll see them here in a minute. In fact, I can show you what it's going to look like. It's going to look like this. We're looking at some of the instructions over there. And what I'm going to do is I'm going to kind of go into what that is. And we'll come back here in a minute and then we'll draw it out sort of the way that I've been talking about, but I don't know if it's going to work that way. You guys will probably have a better way because there's a lot of more learned people out there that know what they're doing. And here I am just going to kind of feel my way through this and see if I can kind of reason my way through it and see what you guys think, because there's so many variables here. And the question is, it's going to be a question of a couple different things. It's going to be a question of winter humidity, and I'll explain what I'm saying, because I want to design a system that regulates humidity better than my current design. And my method for regulating humidity will be the staging of the system. I'm going to alter how the staging works, and we'll see if you guys think that it's going to work like I think it's going to work. I don't know. We're going to see. I'm not sure yet. So here's the first thing I want to do. I want to take a look at a humidistat, which I may put into the return duct. This will just be an example here, and I'm going to flip around over here. And what I'm looking at is a Honeywell H46C humidity controller. And you see this thing has been around for a long time because they have it matched up down here with a T87F. So this thing's been around for a while. You see some of the controls and stuff in here. It's been around for a while, but will it do the job nonetheless? Because I'm a big fan of getting stuff in the system that's easily repaired, proven technology. I like that. I like the whole proven technology thing. I would like to add my own spin to this to make sure that it's going to work properly. So here we go. Let me just kind of go over this. This is the H46C humidity controller. It's been around for a while. There's little instructions on how to mount it. We can figure that out on our own time. It has a dehumidifying device right here. So you see there's L1 and L2, and it's cutting that L1 to either a dehumidifier, exhaust fan, or air conditioner. So that's a pretty straightforward thing. You're either going to have a no-go or go situation. Not going to alter staging. You're just going to turn something on or off. And that's one way you can use this device. So it kind of explains this. And what I'm going to do is I'm going to read this, connections and operation, and then we're going to talk about it a little bit. We might draw it out a little bit as well. I think I need to boost my sound just a little bit more. It's the downside of not having many viewers on the first stream. I can't get any feedback on what it sounds like. So what I'm going to do is boost the output here, and hopefully that doesn't ruin the sound or anything like that. I just want to make sure that you guys can hear me all right. Okay. So, connections and operation. A dehumidistat in combination with the thermostat can be used to run the air conditioner to control relative humidity levels. And that is the goal here. We want the air conditioner to control the humidity. We don't want it to add a secondary device like a dehumidifier to get down to that comfort level, and we have to decide what our comfort level is. For me, I want to see it between 50 and 55%. That's where I would like to see the humidity in the home, relative humidity at all times. And it's not a problem when it's super hot outside, when your AC is running all the time. The problem is when it goes below that design temperature, it's way below the design temperature, and it's not running enough, or it stages up because of a timer or an algorithm or whatever they use, and it stages up too soon, and it satisfies. Basically what I'm saying is it gets to that second stage capacity, it satisfies the sensible load, and there's still latent load left. Okay, so I'm going to continue reading. Wiring in parallel allows the dehumidistat to independently control the humidity level. but could cause overcooling of the home. And we're going to see why that is in a second. During unoccupied times, the homeowner should set the thermostat to a relatively high setting and control moisture using the dehumidistat. Wiring in series prevents overcooling, but the air conditioner runs only when both the thermostat and dehumidistat are calling. So that's a pretty big deal right there. The air conditioner only runs when the thermostat and dehumidistat are calling. Now I'm going to check over here, make sure we don't have any issue. I see the warning sign on the streamer. Let me do something. Let me blow this up real quick, and then we'll get right back after this. This will just take a second. Okay, now we're good. All right, we're good. Sometimes it scares me for no reason. So let me read that one more time. Wiring in series prevents overcooling. So you're not going to get that. I set it on 73, now it's 69 in my house. But the air conditioner runs only when both the thermostat and dehumidistat are calling. So it may not satisfy the sensible load of the home. During unoccupied times, the homeowner should set the thermostat to a relatively low setting and control moisture using the dehumidistat. Okay, so let's look down here. So this says typical wiring hookup for H46C with blah, 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 combination for dehumidification and mildew control. And let's see how they wire it up. So there's an R and an H terminal on this dehumidistat, and the H is going to Y, and the R is going to R. So your Y is your yellow, typically going to your compressor. R is typically the 24-volt hot. Now, there is an issue with this particular thermostat because this is an older thermostat. And the issue I'm going to point out here, and what I'm going to do is I'm going to zoom in a little bit. See if I can do that. How do I zoom? There we go. So if we go to here, we have auto fan on. This is our fan control. You see G down here. So on these older stats, it back feeds through there, that point. So you see if you energize the Y, so you have an R right here. You have your hot 24 volts traveling to the dehumidistat. Then it comes out on the H terminal, it goes over to the Y. You're going to turn the compressor on. Now the problem is you don't want to turn the compressor on but not turn the fan on. You're going to get a frozen unit real fast. On these older thermostats, and this is not all thermostats, but if you ever jumped out the Y terminal on an older thermostat system, you may get the fan simultaneously because it's going to backfeed through there. And the same thing if you jump out the fan, you may get a little surprised because the compressor comes on because it's going right through here back to the Y. So that is just one way to manipulate on these thermostats right here, but it's not going to be what I do because obviously I'm not using a T87F. I'm using a modern thermostat, maybe a Wi-Fi thermostat. Me personally, I could really care less. I do like the Wi-Fi feature, changing the temperature without having to get up, but that's not doing our society any favors, keeping us in the chair. As a group, we tend to be a little bit more hefty than we should be, so let's get up and move, and we'll get a Focus Pro 5000, we'll be good to go. That's another Honeywell stat I'm a big fan of, Focus Pro 5000. I always liked those, used them for years, and I'm glad. I do believe they're still making them now because of the T6 being such a mixed bag as far as opinion. T6 is another Honeywell thermostat. So let's drop down here, and we're going to go to another wiring schematic. It's a different way to wire it. So this is sort of in series. You have your Y from the cooling contactor coil coming in here, leaving, and keep in mind this is normally open, and when it gets to a high humidity level, it closes. So the signal's not going anywhere until it closes. So no matter what the sensible load is, it doesn't matter. And we're talking temperature. We say sensible load, we're talking about the temperature. It doesn't matter what the temperature is until this thing gets a high humidity load. It's not allowing any voltage to go to the cooling contactor outside. And maybe I should have drawn that a different way. Let me do that a different way. So you have your 24 volts Y call. Your thermostat said it's getting hot inside. I'm going to simplify this. I'll be like a mini split manual. The thermostat says it's time for coldness. So it sends out a Y signal here and kind of trace it along 24 volts to the R. So now that that's at the R, it's going to hit a dead head because it's normally open contact. What that means is no voltage is getting through until whatever parameter is met. The parameter that needs to be met is dehumidification, so you need to have a humid load. As soon as you reach a humid load beyond what your set point is, let's say you set it at 55 and it's 60. So you know you're going to have dehumidification that is needed. So it's going to let that voltage pass through there. It's going to come to your H, and it's going to go down and go to your cooling coil. Bam, Your condenser turns on, and there you are. What the issue is that means it's only going to turn on if you have a humid load. So it could be 90 degrees in your house and have a 45% relative humidity, or really low humidity, should I say, and not come on. But it's only going to come on when you have that humidity. Of course, that's not going to work for me. I live in America. We want it to be a certain temperature. We want it to be a certain humidity. We don't live in America to not have those things. So what I'm going to do is I'm going to kind of design it in a little bit different way. Let's kind of talk through it and see what we come up with. And this is some stuff I've thought a little bit of a preliminary thought on, but I haven't thought it over completely. So let's head back to the other screen. I'm going to come back over here to my computer because I have a couple sitting side by side here, and we're going to go to the whiteboard. Okay, you see a black screen right here. That is okay. Do not fret. I'm going to draw an air handler. Very simple. We have a thermostat, and let's say this is the return duct coming off the air handler, because I'm going to try to make this as simple as possible. And we want to sense our humidity in the return. So let's say there's a humidistat right there with a normally open contact. So what do we got to do? I have a two-stage system. That's why this is important to me, because I'm manipulating multiple stages. And what that means is you have a percentage of your total cooling in first stage, and then you have 100% in second stage. So basically you're going to get like 60 or 70% of the cooling capacity in the first stage, and you can get the whole thing in the second stage. So let's go ahead, and those are Y1. That's stage 1. So we're going to put Y1, and I'm doing this with my mouse, so let's see how well I can draw this. And we have a Y2. Let's just go into the air handler. So not the perfect drawing, but these are 24 volt wires when energized. So Y1 and Y2. So Y1 is going to be uninterrupted. We don't need to interrupt a Y signal because we're not going to have any free cooling. We don't have economizers on these systems giving us free cooling. We're going to need that Y1 every time we want cooling. Okay? So we have that signal, and let's say we have a humid load, but the thermostat in place wants to send it to second stage because of a timer, because of whatever reason. It doesn't matter. The thermostat wants to send it to second stage. What are we going to do? So we need to tell Y2 what to do. So if we have normally open, we come around here, we go to the first contact, we don't go over here anymore. So we have our Y2 running to the humidistat. Let's say it runs back out to the unit. So this signal isn't going to go through until we have that humidity. That means this air conditioner is going to stay in stage 1, Y1 only, until it gets that signal. Okay, now here's a couple issues that I see that could arise from this signal, because it seems like it's pretty cut and dry. It's in series, no issues there. In cooling, you're going to be fine unless one parameter comes into place. Excessive sensible load with humidity load. Now, obviously, we're in the South here. If you haven't guessed it already, I'm in North Carolina. So you have excessive temperatures and excessive humidity. So when this thing is going to want to go into Y2 to catch up with that sensible load, if it's humid outside, it's not going to get to. It's not going to happen. Because this dehumidistat is going to say, nope, not yet, not till we get to the lower humidity level. So you may fall behind in a sensible load while you're catching up with the humidity. Now, eventually, you should catch up with the humidity and click into Y2, so it shouldn't be an issue. But that could cause an issue with catching up on temperatures. You may run a higher temperature, but it may be something where that's an acceptable kind of self-made algorithm right there. You're going to be up at 74, 75, 76, but it's going to feel better inside because you ran on first stage. That's possible. I haven't tried this yet, and our summer is kind of past, so I'm kind of past for this. But let's look at a different aspect of it. Let's look at the winter time, because this is a heat pump. A heat pump's going to use the same Y1 and Y2 in the heating cycle. Only difference is for this particular system, it's a heating active reversing valve. Without going into too much detail, in heating, it's going to energize a valve that changes the refrigerant flow. A lot of systems have that energized in cooling, but in this particular case, this is a Bosch system. Bosch is like, the most famous one I can think of is Rheem and Rudd. They have that heating active reversing valve. So what's going to happen is a couple different things. We're going to have stage 1 come on, but if we have a humid situation in wintertime, which is less likely, it's less likely in the wintertime because we have colder temperatures outside. Typically our humidity levels total are less. And we're talking about cold temperatures outside, and even if the air is saturated, we're like 40 degrees or 45 degrees inside, we have the latent load that we're producing, like humans, we're cooking, we're walking around. Just being humans produces latent load. We're watery devices walking around here. So we have those loads, but we're expanding that air and heating it. That means there's more capacity to hold moisture. Your relative humidity drops down. So we don't have the issue in heating that we would in cooling. Not to say it's not possible. We could still have an issue with excess humidity, especially in areas that humidity runs higher, like the southeast, like where I'm at. Okay. Assuming we don't reach that point because it's wintertime, this thing will not be a factor. Okay? But on certain machines, Y1, then Y2, that's our heating cycle, stage 1 and stage 2, and then we're going to have a third, which is W, heat strips, W1, W2, whatever you want to call it. The heat strips come on. So what we can't have happen is this signal get misdirected and deadhead right here on these open contacts, and then this Y2 signal comes on, and because we don't have a Y, or this W2 signal comes on, and because we don't have a Y2, our blower is not staged properly. And perhaps it's not a big deal when the W2 comes on, the blower may stage up naturally, but some systems don't take that into account. It's a Y1, Y2, it doesn't take W2 into account. The problem with that is you have excess heat because your airflow has remained low. The thermostat thinks Y2 is on and thinks that second stage fan is on, but we're kind of tricking it by putting this humidistat here with these open contacts. So that is a potential pitfall. One way I could see getting around that is adding a relay. And if we add a relay, we can bypass this whole setup right here, and we can utilize that. Let's see, let's think about it for a second. If we have a relay in there, let's say we add it, we're going to go ahead and add it right here. I don't know if I can erase. Let me see if I can erase. Let's see what we got right here. I can clear the board. All right, let's clear the board. Let's do that. All right. Make sure I do. Okay, there we are. All right, so I'm going to put the same air handler right here. We're going to put just Y2. We're going to put the thermostat. We're going to have our Y2 signal coming straight over here. That's what it normally would do. And we have our return duct. Hopefully I do this right here, guys. With our our open contacts, because it's humid outside. So the only difference between our cooling cycle and our heating cycle is going to be that energized. Well, there's a couple things. Of course, the temperatures will be different on the supply side, so we can utilize whatever method we want, from some sort of thermostat on the supply side where if it heats up enough, the contacts will open or close on a relay. We can figure that out. What I would like to do is just make it as simple as possible. Now, if we have a relay right here, let's think about what we have to do. Let's take the coil voltage for this relay. It's going to be 24 volts. Of course, we know one side is going to be common. And the other side, what can we do to open or close this relay? I think the best thing to do would be to use our Y2. So we'll go to the Y2, come around right here, and then we'll have our relay. So now whenever this is energized, our relay will either open or closed. So what we can do is we can actually take an R wire from this particular device here, the air handler, because that's where the transformer originates. Just in case you don't believe me, there's a picture of the transformer inside. Proof. Of course, I'm just kidding. So if we have an R wire here, which is our 24 volt hot, we can take it into one side of the relay. And whenever this energizes, this will be normally open as well, it'll send power out to the Y2. So that way, whenever we have that coil energized, you know, that's we're gonna have to switch that up. Actually, we're gonna have to switch that up. And I made one mistake, guys. I made one mistake. I meant to put in, and let's start that over. Actually, I made one mistake right there. Oh my gosh, I'm gonna redo because I'm gonna make a chicken scratch mess right here. All right, I made one mistake. Here we go. Let's do this one more time. We have our Y2. We have our humidistat. We have our normally open contacts. And we have our relay. So our relay will be right there, normally open. All right, we know this is going to be common. It always is. Common 24 volts coming from the air handler. And what we need to do is we need to open and close this relay. So what we're going to use is we're going to use the B wire. And sorry for the mistake there, guys. I had my mind at a totally different spot. The B wire is going to be our reversing valve wire that energizes in heating. And when that energizes, this will close. So it's normally open, and when it energizes, it'll close. So we can rearrange how the power goes to this device. It comes back to the air handler. So what we're going to do is we're going to use the B wire, and I hate to dump too much stuff on you guys at one time. I wanted to get into this a little bit because this is what I'm working on, and I gotta think through it too, because some of this stuff is on the fly, and it can get a little bit complicated after a while. So this relay is going to power that, and then so your Y2, what we can do there is we can come into here, and we'll have a normally closed contact too. And I'm going to think this over, guys, because what I'm doing is I'm running into here, and I haven't thought to this point already, so I'm going to have to think this over and see if we can't do that. In fact, we can take this time here. Hell, I could play a sponsor thing while I think about this. That's perfect. So I'm going to play one of our sponsor things. I got to think about where we're going to send that controls. And speaking of controls, it's EWC. Let's do that. The best forced air zoning controls in the HVAC industry come from EWC Controls. This includes the workhorse BM Plus 3000 zone panel, 3 zones, multiple dip switches so you can customize the controls to your particular system install. Another workhorse of the system is the URD and ND dampers. These power open, power closed dampers are both reliable and long lasting. So for the entire life of your system, you won't be replacing your zoning components. And lastly, the innovative SBD2 static pressure bypass with the wireless NFC interface take this whole thing to a new level of precision and reliability, because you can set your system right there at your fingertips to the particular static pressure you need. No more guesswork, no more barometric arms. Go to EWC Controls Incorporated. You can find them online to learn more, and look for them in your local supply house. Okay, I'm sitting here and I'm having brain farts nonstop, because one of these things is when you work with these relays, there's about a million things you have to think about at one time. So we're gonna do this one more time, okay? And I'm gonna take my time and think my way through this. And you guys, if you ever watch this thing, once we get going, have a few more subscribers, and you want to chat in here, chat about different methods, I could use your help. It'd be awesome, because I'm thinking this through, using my field experience to kind of design something on the fly, and you guys have that same experience, so it'd be awesome to get your input on it. And I'm going to draw our relay. I'm going to try to do this where I don't get myself brain damage again. Oh, wait, we have a relay. All right, and I want to do this. This is normally open contacts and normally closed. So what we're going to do is we're going to have single pole double throw. Top contacts across, normally open. These contacts through here, normally closed. All right, let's just get to this point and reason through this, and then we can go from there. So first we're going to have common, and we're going to have our B. That's our reversing valve energized. Now we're not altering those circuits. We're just going to take from the wire nut where they come together in the air handler, just add another wire to that. We're not going to wire anything in series, anything like that. We're just going to bring extra tails of those wires out here outside the unit to this relay. So in cooling operation, this thing isn't energized. Okay, we don't want this relay to make any difference in cooling operation. So we want that Y2 to run directly here. That's where it's going to go from now on. It's not going to go to the air handler. It's going to come in here. So when it's not energized in cooling operation, we want it to head right over here. Now let's see if we can make this work out. Because one of those things here I can see coming up is we got to watch the back feeding of electrical voltage. We got to make sure that what we do is going to work out on the back end too. It's not going to back feed and just cause this thing to be null and void. So if it's going to go straight through here in cooling, because it's normally closed contacts, these two are not, this one is not energized, so it's going to pass right through in cooling, go to our humidistat, go in one side, come out the other. So if it goes in one side here, comes out the other, it's going to go right back over here to the air handler. All right, so that checks out. That's fine. So let's see what happens now. In heating, we need it to come from here back to here. But is that going to cause a problem? Because if we're energized in cooling and heating, we can't have the voltages interact with each other. Let's say we have, let's say in heating. Okay, let's see what happens in heating. Are we going to have an issue with the humidistat? So we have voltage coming from Y2. It's going to come to this point on the relay. In heating, it's going to come to here, and it's going to go on to this location here. It's going to backfeed back to here, but it won't matter because it won't go anywhere. It's not cutting anything off. It's not doing anything. So in heating, I think that checks out. That's good. All right, let's see what happens in cooling. In cooling, the voltage comes out of the thermostat, heads into here. We don't have a call, so it deadheads right here. It's not going anywhere. It's not going anywhere. Wait a second. I just got that reversed, didn't I? Like a doofus. It's coming through here, here, and here, of course. I'm such a ding-dong. I just did it in reverse. In cooling, we're leaving the thermostat, going through the relay, into the humidistat, and then whenever it closes, when the humidity rises, it's going to, or when it closes, when it's humid, I think we have a problem. We definitely have a problem. So let's see. When it passes through here, dehumidistat, and it closes on rise, it's going to go through there. Okay. So we need opposite contacts. What are we going to do about that? We might need a dehumidistat would normally open and normally close contacts, so we can cause it to, so we want it to, as it gets less humid, to close, not more humid. So what we want to do is get a device where as it falls and gets less humid inside, it lets the voltage go through. Because when it's more humid inside, we want it to stay in first stage. So it might be where we need a multiple contact dehumidistat. Interesting. So when we get lower, we could actually use a humidistat. If we have a humidistat, as it gets lower, it's going to have a call because it wants to turn on a humidifier. So we can just use a humidistat instead of a dehumidistat. I hope I'm not confusing myself and everybody watching this too much, because I'm just trying to reason through this. And we're going to do a little bit more of this. I'm not an HVAC scholar, as you've noticed over the last half hour, but I do like reasoning through all this stuff, and I try to do it in a way I'm not going to make too much of a mess, but I feel like I probably made a mess, and we'll get better at it as we go along. So let's see. Let's talk through it one more time to see what happens. I have a thermostat. It's sending out a Y2 call now. All right. The Y2 call's going here and passing directly to the humidistat. If the humidistat says it's over 55% humidity, it's going to have a call. So it's going to let it pass through. So what we need, if we have a dehumidistat, let's say we have it set on 55%, or a humidistat on 55%. I'm saying all the words backwards now. Just too much. Just too much. So let's say we have a humidistat. I'm going to write it on there. Humidistat. So when it's under 55%, it's going to energize. So it's going to pass through there. When it's under 55%, we're going to let it come on through there. All right. So our Y2 will pass through. If it's over 55%, it doesn't need humidity. So it's going to say no passing through there. And that's how that's going to work, guys. I think it'll work just like that. So we can still place that on the return duct. That's where it'll be. We just have the reverse of the contacts. So it'll be pretty interesting. So we reason through here. We see that my original plan, it does not work. We need a different set of contacts or a device with multiple contacts, open and closed. Because some of these devices might have both sets of contacts. But if it has one or the other, you can always make it work with a relay. So, guys, I want to know what you thought of this. This is kind of is one of my wacky plans, one of my wacky talks. So I'm going to rename the title something like Reasoning Through Dehumidification Processes, so I can kind of indicate that we're it's a work in progress. So I hope you guys like that. I know it's kind of a long video, a lot of back and forth, and just if you liked it, please give it a like and let me know in the comments. Not edited, all live. So when I have to reason through something, we have to take a moment and reason through it. And I like doing that. I like doing live stuff. I like seeing you guys interact with me and stuff like that. So I'm going to keep on doing it. But just keep in mind that we're going to be reasoning through stuff. So you're going to see some things and you're going to go, that's not right. But I'll figure it out eventually. Or you can help me figure it out. So we'll figure out the best way to do something, and by experimenting with different ways, we'll kind of grow our intellect in this particular area and start to uncover some other knowledge probably along the way. So hope you guys enjoyed that. My name is Zach Ciota. This is the HVAC Training Videos channel. If you enjoy this, you can check out some of my other channels. We have a giveaway channel called the Skill Trade Up for our HVAC tools. If you like that, want to win some tools and answer some trivia questions, you can head over there. If you just want some general HVAC knowledge and entertainment, try the HVAC Shop Talk podcast. Guys, hope you enjoyed it. Girls too. I'll say girls and guys. And I will see you on the next one.